So to give you a bit of background, I mean, yes, I can write code. You probably don't want to deploy the code that I write. I'm a network guy, not a coder. So I guess I'm coming at this more from that perspective. So really, yeah, to look at where are we going with cloud native network functions. I guess you have to start by understanding what does Kubernetes provide today, and what do other container networking solutions provide, and particularly as you get into the different CNIs in Kubernetes. So whether it's Weave or Calico or whatever, what do those do today? How does that work? And I think the fundamental issue is everything up to now is very much premised on the fact that what you're running is an application rather than a network function. So I think we had some discussion earlier today of layer 4, layer 7, etc. And it tends to assume you're at that kind of socket or above layer. And I guess that then becomes a problem as we go, of course, to network functions at layer 2, layer 3. Particularly because you're dealing with applications, you'll tend to do things like NATing everything. So both as we talk to the outside world, but even within a Kubernetes deployment, you'll have a service that maps a cluster IP onto a set of pods, and you'll map that at ingress. And very much it's all about the policy that Kubernetes itself has, like Nikos was just showing, and that's really about who can talk to whom in the overlay, and that's really, again, seen from an application perspective. And yeah, very much designed around, okay, I want to deploy a bunch of applications into a data center, but what if what I want to deploy into the data center is a bunch of firewalls or DPI or some sort of custom network function that I've written? And so what would we need to do those things? Well, we'd probably want our policy APIs. And one thing to say straight off the bat, I guess, is that yes, we're doing this in Legato so far, but there's still some gaps apropos of this stuff. So we haven't yet got to as far as we know we need to get. So really you want your policy APIs to be more network-based. I think somebody earlier today talked about, how do you define how much bandwidth you have between here and here in Kubernetes? Well, that becomes relevant where what you're doing is actually a network function. And things like QoS, though, I'm not a great QoS believer, but those sort of things become issues. And of course, in terms of how you do the networking, clearly you don't want to put NAT in the way, because the moment you're doing layer 2, layer 3, for a start, it is a bottleneck, but actually it's plain going to break things. You probably don't want to go and look down into that far into the packets. A lot of the network functions you're going to do are likely to be sort of bumps on a wire, where it's pure layer 2. You're not looking at the IP addresses until you get into the network function. So the wiring should ignore that. And you want to be able to wire to the outside world, of course. You get the classic use case where people want to do virtual customer premise stuff where they're deploying it into a data center rather than at the customer premise itself. So you need to hook into the outside world. You probably want to also be able to hook into application containers. And also, of course, you want to be able to chain containers together, either just a couple of them or even build these long service chains, which might include physical elements as well as virtual. And really in terms of how you orchestrate and manage that, and I think this is where you get to the stuff that Ed was talking about with respect to network service meshes. Because if you think about it, in Kubernetes, when a pod dies that's providing a service, you can just spin that pod up somewhere else. I guess the question becomes, what does that mean for NFV? Because you don't just have this one address that you're natting from a service address to the one address on a pod. You've now got something that has an in and an out. And how do you, when something dies and comes back up somewhere else, how do you rewire that? And really, that's something we have to handle from the orchestration perspective. And I think the network service mesh approach is probably the way we want to go with that. And conceptually, when you think about this, it's all about early versus late binding. And DNS can give you a cluster IP, but having got that cluster IP, which pod you go to is very much a live, real-time thing. And with NFV, it's going to presumably be the same, that we want a very late mechanism to say, okay, here it is. It's just moved from over here to over here, and we need to rewire it. And banging on, I guess, the VPP FIDO drum. We don't want to be forwarding in the kernel, so how are we going to move this to VPP? So really, we've probably already shown this slide a few times today. If not, here you go. So here we are today. On the right-hand side, Fido. There on the left-hand side is what we're going to be doing from Wednesday to Friday, Kubernetes. And really, what I'm talking about today is the stuff that goes in the middle. So Ligato, which is our infrastructure for building cloud-native network functions. Contiv-VPP, really, I guess you could see as an instantiation of that architecture, and I'll come on to why that's so. And really what we're looking to, as we say, is enable production-grade native cloud network services at scale. Now, in terms of scale, clearly, again, the benefit going to containers where we don't have the overhead of individual virtual machines, using things like Memif to stitch the containers together so we have single copy rather than very intensive I/O. And so to achieve orders of magnitude more scale than we've had up to now with virtual machines. But if you take that picture, that's kind of a sort of view of how we fit it all together. But what does it mean when it gets deployed into the network physically? Well, one of the keys, I think, in everything we've done, I guess Nikos was talking a lot about Go and the fact that VPP is written in C, but the Kubernetes, the cloud world's all very Go-centric. Equally, what we wanted to make sure with all of this was that we leverage the sort of cloud-native tools and technologies. So, you notice the use of etcd as the distributed data store, the use of Kafka as the message bus. Very much trying to apply the cloud-native approach. And I think as Ed was saying earlier today, even at the case of a vSwitch, what we do is the vSwitch itself is just a container, or a pod, in fact. So we take VPP, we take the Go agent, and we deploy that as a pod. So it's very much, the whole thing is cloud-native. So back to Contiv-VPP as an example of this, and of course Nikos showed this slide with probably very, very minor differences. How does that fit together? Well, it's, as I say, we're using the Contiv infrastructure, the Ligato infrastructure. I guess the key thing we're using in this case, though, is the VPP agent itself that programs the VPP instance, which in our case here is the vSwitch. We mentioned earlier today, because Florian was talking about the host stack. So the assumption is that people will leverage the host stack to get higher performance, but equally, you can use veths and taps today with existing apps, and that will work just fine, modulo the performance constraints of going back through the kernel. I've shown the different network types, and I think it's one thing to say, what I'll show next is how we do this with VXLAN today, but the longer term strategy is to have other encapsulations. And obviously SRv6 from a Cisco perspective is particularly interesting. And I think what's going to become interesting as we move into the v6 space is that, I mentioned the ingress NAT that we do in Kubernetes from the cluster IP to the individual pod IPs. Well, of course, NAT is sort of an anathema when you get into the v6 world. So we have to come up with a solution that doesn't involve NAT. Other interesting things, for example, how do we do the load balancing? It might be with SRv6 that we can do something a little bit smarter than just doing a round robin. And again, that's for future discussion, I think. So how do we render this with VXLAN? Well, the simple thing is to say, well, and this is actually a question, I guess, is up for debate in terms of whether we think that management is typically going to be out of band, or whether we think the management interface is going to be the same interface that gets used for I/O. And as somebody was saying at lunch, I think it was Pierre, about well, if you've just got the GigE LAN on motherboard port, if your applications aren't I/O constrained, if they're compute constrained, why wouldn't you just use that port? And I take that point, but of course what we're attempting to do here is to have a high performance infrastructure. So I guess my assumption is that very often people will have some kind of a daughter card with much higher performance NICs on it. And so that you would use your LAN on motherboard port for your sort of controller management plane, but you'd use your 10 gig NIC or whatever it is for your data plane. And so in that data plane, what you do is you basically create a single VXLAN mesh that ties all of the nodes in the network together. And on each node, what you're going to have is a bridge domain which hooks into that VXLAN mesh. So you'll have multiple VXLAN tunnels running as a split horizon group, so you don't bounce stuff backwards and forwards. And then you'll also have a BVI, so you have an IP address in that bridge domain, and then everything from your various applications will get routed through that subnet effectively we've built as the interconnect between the nodes. So how do we do this? So as I said, I'm a network guy. I used to type Cisco, actually I still do, type Cisco CLI far too much. So the way I tend to see things is in CLI. Now, of course, in Contiv-VPP and Ligato, none of this stuff's happening in CLI. It's all happening through the API. But what do you do from the CLI? Well, you start, of course, by creating that bridge domain. Then you attach a VXLAN tunnel to it, and you do one of those for each remote node in the mesh. And of course, when you're running this in a system, the system's got to track nodes being added and deleted from the mesh and stitch those in at runtime. And then, of course, finally, we need to create the BVI, so we create a loopback interface, we tie it into our bridge instance, we give it an IP address, and away we go. What that looks like, I thought just for fun and risk of something going horribly wrong, I would actually show that live. And of course, it would help if my windows were in the right place and if I could see what my mouse was doing. Okay, let's get the right one. So this is, I have a deployment here. I'll sort of blow this up a bit so hopefully you can see it. So this is actually running on a lab in San Jose, and it's a bare metal deployment. And oh, I've gone the wrong way. Sorry. See, you knew it was going to happen. At the bottom. Oh yeah, on this one. On the one I can't see. Yeah, great. I've got to undo that when I come back again, of course. You knew this was going to be fun. So let's make that bigger till that disappears. So hopefully you can all see what I'm doing. So what pods do I have running? So what I have running at the moment is I have a deployment. In fact, yeah, if you show us deployments, yeah, so you have a BusyBox deployment, which is actually running on my master just so I can ping around stuff. I've spun up 4 Nginx instances. There's nothing really in them except a page that tells you the IP address of the responding web server, which is quite useful when you're doing load balancing to see what's happening. So if I do I really should have given this BusyBox pod a name that didn't involve me cutting and pasting each time, but so we'll go into that one. Oh, I was going to say, so what I did then also is I created a deployment, a service instance, which is basically 10.96.1.1 is the cluster IP. That maps onto all of these Nginx instances. So if I do, it may complain that the file's already there because I was testing this earlier. So that works, but if I do, there you go. And you can see the server address it's given me is that one. If I get it again, you'd expect to give another one. Yeah. They'll probably complain, yeah. Just trying to get it to go onto the other server. There you go, it's gone onto the other server. So, and finally, if I do one more, I'll probably get the other one, 10.1.2.3. Yeah. Of course, that's why I should just use back arrow. See, it's gone back to that one. There you go. Probably because I left it too long. The other thing to say, of course, is you can get the individual. You can, of course, go straight to the pod, as long as you've deleted that. So that all works. Oh. The other thing, I think Nikos may have already shown something effectively like this, but what we've implemented in in VPP is all the same logic that would be in kubeproxy normally. So I think the Intel thing earlier that Ray was presenting about the kubeproxy and VPP. In this case, we're effectively bypassing kubeproxy, but doing all the same logic. So you can see for my service address of 10.96.1.1, I've got these 4 different pods that are implementing that, all with the same probability. Right, so back to the deck. So I need to unmirror. This is great. Great. So we just did that, didn't we? Okay, so the next thing is the VNF case. So in the VNF case, this is going to be slightly different because what we want to do is to chain together potentially multiple network functions, they themselves running in pods. And typically those pods would contain a VPP container, and the VPP container would either be front-ending something or it itself would be the network function. And I think there's room for some debate there on sort of when do we want to create something as a single forwarding graph in VPP, and when do we want to break it up into different network functions that communicate over a memif rather than being part of the same graph, even if those are actually both running on VPP. Because one might argue you could combine them into one VPP instance. And I think a lot of that is going to come down to things like policy, things like, well, did you code all these yourselves or did you get some of them off the shelf? And I think that's, again, something worthy of debate as to how we would do this. And even thinking, well, when it comes to memifs and linking functions directly sort of east to west within one node, you could say, well, in that case, your policy is probably that they should land on the same node, at which point you kind of say, well, why wouldn't they be in the same pod? So back to those same sort of issues. But how does that, I think I covered that one. So the key thing, so this SFC controller, what it's got to do is figure out from this logical representation, how do we place that onto the network and what's that physical representation in the network? And as I said before, the challenge then is going to be, well, if something dies and needs to come back up somewhere else, how do we do the rewiring? And so logically what you're going to have probably is the same sort of idea of a separate management network, even if it is instantiated on the same physical fabric. You'll still have a network that's going to carry all sort of control plane, management plane interaction. But then you're going to have the data plane networks. And again, there might be one, there might be more than one. And if you look at how you then render that physically, if there's more than one, those are probably going to be different VRFs in VPP from a sort of underlay perspective. What's going to be different now is how do we do the overlay that we put over that? Because if you remember, I showed in the Contiv-VPP case, we just have that one single mesh that covers the whole network. Well, in this case, because we're stitching individual things together, what we're going to want to do instead is to have these sort of individual little segments that connect different network functions. And really, if you're within one node, there are 2 ways you could do this. You could stitch directly, as I mentioned, east to west. The challenge there, of course, is they've got to be co-located on that node. If one of them fails, you're going to have to reinstantiate it on the same node. So there's an affinity type issue there, though, again, as we show, who was showing that earlier? Probably with the labeling. I think it was back to when Ed presented the whole thing of Kubernetes and labels, and it's very easy to say, well, here's a label that says these things have to stick together, what sort of node they run on. But it might be you decide to go via the vSwitch, either because you want them to be able to move onto different nodes if required, or because there might be some sort of policy that you want to infer, between the 2 network functions, and you want to do that in the vSwitch. Point to point, really the most likely scenario, between nodes is going to be just have a single VXLAN tunnel to connect the 2 network functions, give it a dedicated VNI. You could imagine reusing one VNI all the way through a chain, but then you have to deal with the issue of what if I'm connecting to this server and then back out to this one. And so I think one easy solution is just to say that each link in the chain is a dedicated VNI, and you've got 16 million of them to play with. This is the VXLAN case. Again, if you're using something like SRv6, you'll probably render this slightly differently. And then, how do we do this? And again, back to a CLI diagram. So the first thing you want to do is create your memif. Having created it, I can see that Damian's looking at me going, he's going to get this wrong, he's going to get this wrong, because I was playing with this today. The next thing you're going to do is create your VXLAN tunnel. The funny thing with the VPP CLI for VXLAN tunnels is you don't know at the point you create it what the number of the tunnel is going to be. So that actually gets returned to you when you create it. And once that's been returned to you, you can, in fact, the same, with memif, it presumably, Damian, the master always gets /0, does it?
I think they fixed that recently.
Oh, okay. So then the other thing to watch out for when you create the cross-connect between them, and this is another thing with VXLAN. The thing I showed before was VXLAN binding to a bridge domain, but if you think about it, if you're doing sort of point-to-point stitching of network functions, why would you want to bind into a bridge domain and have to do MAC learning when you could just do a simple cross-connect and effectively create a pseudo-wire through the network? So in that case, there's no bridge domain here. You just have the two interfaces. The funny thing, or the slightly strange thing, is you have to basically connect one to the other and then vice versa. So having done that, you should be able to communicate through the service chain. I will now show a very quick instance of this in the time I don't have. I will remember to go back to the little mirror button. I love it when the screens are back the wrong way around. Oh, these are probably going to need to be blown up a bit, aren't they? Right, so we have two vagrants. This is, in fact, the same vagrant thing that Nikos was showing earlier with some stuff deployed into it. Got to remember what I've got. So I've got 4 VNFs running, 2 on the master and 2 on the worker. I've untainted the master so that you can run deployments on it. So if you look at it from the point of view of the VPP, on this worker, for example, you can see you've got one VXLAN tunnel that was created for Kubernetes. We've got a couple there that have been created for these to stitch these VNFs together. The first one's already seen some traffic. That was me testing it just now with some pings. You'll also see some memifs further up. And again, you can see some pings have gone through that memif. So if you actually want to look at the container itself, hopefully it's there in my command history. Yeah, so this is the VPP instance now in the container that I've jumped into rather than the main instance. And what you'll see is there's only 2 interfaces here. We've basically got the default local 0 and a single memif. So if we look at the memif, there's an address on it. You can see I've already done a couple of pings. Funnily enough, 10.0.10.1. So you can see that. So this is now pinging from this CNF into my local vSwitch. It's then cross-connecting there in VXLAN, going across the network between the 2 nodes, and then coming back out to a network function at the other end. And you probably see 5 pings now, yeah. So you can see a few more packets have gone through it at that point. And so, yeah, you really just chain those together. So if you were to have a more complex network function with in and out and going out, so say to nodes either side, you would just create another VXLAN tunnel, one for each direction, with the cross connects. Oops. Right. So we're now on the home stretch. Right, we showed that. So yeah, I think really all that's left to say is, of course, this is all out there in open source. We've seen it all today, but all the Ligato stuff's up there on GitHub. The CN Infra, which is the base, the VPP agent, which we use, which runs on top of the CN Infra and is required for Contiv-VPP as well as for Ligato doing VNFs. But the SFC controller, which we only use in the VNF case. Right.
Last questions?
Yeah, fire away. I can't promise to answer them, but then I have all the people who can in the room, so.
So just on that, why do you host it separately on Git?
Separately from what? Sorry.
Separately from
Oh, yeah, that's a good question. I have no idea.
Because what that does is that you know it becomes makes it harder to find.
Right.
You know, if we're trying to for an end-to-end story, if you're trying to say an end-to-end story for Kubernetes, for Kubernetes infra, it kind of becomes disconnected in a way.
Yeah. Yeah, I don't know. We could put a link in the other way as well.
I think initially the idea was to have some coordinate, like a platform that develop DNF agents, right? Benefit of VPP or something else.
But I mean, the Go VPP stuff's hosted in Fido, isn't it? So we can maybe put something there saying, oh, and by the way, one of the things that consumes Go VPP is this VPP agent, which is part of Legato and Contiv-VPP, which might give people that context. But yeah, I mean, the CN infra, again, it's all just plugins. And so you have the base platform, then the VPP agent, effectively kind of plugs into the CN infra, but it itself then uses plugins for all its functionality. The SFC controller is a little bit standalone. Again, are we there? Yeah. So it uses the sort of APIs for the VPP agent, but it itself is running on the master. It doesn't need to configure anything on that host because it's using etcd as its mechanism to get effectively the rules out to the individual hosts that are running VNFs. As I mentioned before, the SFC controller, you wouldn't use that if you were just in Contiv-VPP. It would only be if you want to have cloud network functions that you need the SFC controller. So I think that was pretty much all I had. Do we have any other questions, or do we just invite the panel up?
Questions?
He says hopefully.
So you get a free drink bought by me for
Been
getting
quick.
us back caught up on time and not running over. So,
But to be fair, I probably only did that by talking so fast that nobody understood a word. So, swings and roundabouts, swings and roundabouts.
any questions from anyone? All right, cool.